The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We're starting the half-hour free training session, SolidCAM Live today. With me, as always, we have Kevin Rankel. Hey, Kevin, how you doing?
Doing good, everyone.
Perfect. And that's going to be my opening until somebody tells me different. So last episode, I asked for a proper opening. Nobody gave me suggestions, so we'll continue to do that that boring opening. Also, from the last session, we talked about Cartesian versus polar, and we got a lot of actual feedback on that, both internally and externally. If you've watched a lot of KevCam, you know about Greg Payton. Greg Payton actually gave me some details as to what I should probably go a little further into with respect to Cartesian versus polar, because in the last episode, we talked about it as a concept, the coordinate systems and how they could be used. Let's talk about specifically how they are used inside SolidCAM, because obviously that's what we're here for. Let's see how we actually use them. So as a bit of a review, when you are doing any kind of toolpath, like a 2.5D toolpath on your mill turn machine, you have this fourth axis control section. With the box unchecked, this automatically outputs as Cartesian coordinates. And if you remember from last episode, that's basically X, Y, and Z. If we take a look at G code from that, which I have saved, you can see it is a series of X, Y, and Z coordinates, basically what you're familiar with on the milling side of things. And if we were to look at the machine sim, like we saw last time, basically that is, if we open this back up, let's go to machine sim. And I actually have a different machine sim this time because I wanted to post the code a little more specifically. So once this machine sim pops up, we're doing that hex pocket with a non-rotary with the box unchecked, so not engaging the fourth axis at all. We get that XZ coordinate system, and let's zoom in on that. Get rid of the machine. So there's our end mill. It's going to do the hex pocket, and if I play through this, the tool moves, the turret moves, the part stays stationary. That is general Cartesian usual milling toolpath. So there's nothing rotary about that, nothing fourth axis about that. So let's exit out of there. Now let's go to the same pocket, same geometry, same tool, same machine, but with the box checked, but also set to Cartesian. Now this is different in that it is using Cartesian coordinates, but you can see that it's in the plane X and C as in Charlie. So what this actually is going to do is generate a toolpath that if we look in the machine sim, and again, I'm going to be going back and forth between the machine sim. So this time I'm actually going to leave the machine sim open so we don't have to load it every time. But this one is using the fourth axis checkbox set to Cartesian. And once we load this up, this will be the difference between Cartesian without the box checked, because it's default, and the Cartesian with the box checked. The part now moves. There's two things to keep notice of. On the right side here, under our move list, you can see that it's moving like you would imagine a move. It goes between certain coordinates and such. We're going to take a look at the G code a little more specifically to see what's going on there. But I want you to take a look at that, how fast that's moving. And then once I click on the same pocket, the same tool, but this time with the box checked and set to polar, also in the XC plane. But once we run polar, take a look at the move list once I press play. It's moving a lot faster, meaning there's a lot more data points for it to be going through. So that's one main difference between the checkbox for fourth axis Cartesian and fourth axis polar. Now let's actually pause this and we'll take a look at the two G codes. So here is the one for Cartesian. You can see that it also uses X and C code, but the difference here is because of the way that this code was posted. Now on your machine, with your specific post, it's going to be a little different machine to machine, but basically you're looking for this sort of coordinate system conversion. And with fourth axis engaged, using the Cartesian output, X and C, this is essentially the same code. If I can bring up these two. Let's put these guys side by side. You can almost see they're exactly the same, except that with the node rotary, we have Y. Let me highlight that. And then in this one, we have C. So that coordinate system conversion, either on this particular post, it's G112, on other machines, it's G12.1, whatever it is in your G code to do the conversion. You're basically looking at this as X, Y, and Z code for non-rotary, X, C, and Z code, or let's do it in Canadian so everyone can pay attention, X, C, and Z code. Basically, they're the same. It's just that on this machine, with the conversion, we're now engaging that fourth axis. So instead of Y movements, we're getting C movements. If we take a look at it with the polar output, there's a lot more lines of code. If you take a look at how long this is, just by this bit right here versus the Cartesian, there's a lot more lines of code. And that's because of all those rotary movements. This is pure rotary code. It's just X and C, and there's a lot of C movements. So what does that actually relate to in terms of what we're doing with the pocket? Well, let's go back to my whiteboard. On the left is fourth axis output Cartesian. On the right is fourth axis output polar. They're both using X and C coordinates. But on the left, because it's Cartesian and it's still looking at it almost like it was X, Y, Z code, instead of, in this case, it's X, C, Z code, it's looking at data points and still doing a linear motion. So in the G code, we're basically just getting that point there, and we're getting just our linear motion to make our little hex shape. Fourth axis polar is all rotary movements. So it's a lot of little arcs. And if I bring up the, let me minimize this so we can take a look at what all that means. Let's exit out of here. All of those little arc movements are actually being output because when you use fourth axis polar, you actually should use interpolation by tolerance and put in a value there, and then approximate arcs by lines there. Those two values there basically represent the little arcs. So these are all the little interpolations here. These are about the 39th thou or 39 tenths or whatever was listed on my toolpath. And as it goes along to make that straight line, it's actually just a series of tiny little arcs. So that's what all those lines of code in the fourth axis polar represent. And the reason I have these lines here is I'm hoping to represent here the fact that as this goes along, it has an X coordinate, a C coordinate, and a Z coordinate, and then an X, C, and Z coordinate for that to make that line. Each one of these is actually a different X coordinate because it's actually changing the radius of that rotary as it goes along to maintain that somewhat of a line there. And a little more specifically, here's some literature that again, after getting some expertise from Greg Payton, gives us a little better look here. So you get that straight line there, or you get these little arc kind of movements here. Hopefully that's coming through to you guys. If not, let's make that a little bigger. So it's the same hex, but this one has to be done with a series of arcs. So does that make sense for everybody? Because this is the kind of thing that is complex, but hopefully when you dumb it down like this, it makes a little sense. But ultimately, inside the software, you're just checking the box and you're telling it what kind of output you're looking for. In both the Cartesian and the polar, with this box check, it goes back to what Kevin had said last time. If you don't have any Y movement, or you're looking to reduce the movement of your tool and you've got it on a rotary and you want to take advantage of that, both of these do that. If you remember from the machine sim, the index is happening in both cases. It's just between Cartesian and polar, you're looking at the size of code and basically the simplicity of the code. If you set it to Cartesian, it makes sense to you. There's an X coordinate and a C coordinate. You know where that's going to fit on your part. If you're looking at polar, then that changes a lot, and it's all those little arcs. So you're basically looking at it with a little more detail. You've got a larger file, and that could be a limitation for your machine. Maybe you have an older machine, it can't handle that much data, or if you're trying to drip feed it, that's not going to help with this sort of thing because it moves too slow. Whatever your machine is capable of doing, you'll choose either Cartesian versus polar. So does that make sense?
Okay, so we do have one question. How does this apply to machines like ours where the fourth axis rotates on the head/spindle and not the part on the rotary?
Head/spindle. Maybe I don't understand. Do you know what he's talking about there, Kevin?
No, I'm a little lost.
So our part is stationary and our spindle rotates around. Now, is that a right-angled head on your machine, or is that like a 5-axis machine there, Jake? 5-axis, okay. In 5-axis, this is a different story. This is 4th-axis output for like a mill turn, I guess.
So we have a B and a C. Yeah, so this is more geared towards Jake, the mill turn side of things, not
Yeah,
5-axis.
I don't think you would see this output if you're doing a 5-axis, because if you're doing 5-axis, I mean, with the 5-axis simultaneous toolpath, you can limit it to a 4th-axis output, but I don't think you get this same functionality with that, because this is more of a mill turn, lathe, live tooling kind of deal. So I'm not sure if that fully applies, but because of the feedback we got for the last episode, I want to make sure that this is clear. I want to make sure that this makes sense. Otherwise, we're having a part 3, and we'll go into even more detail. But basically, that's what this represents: just the output that you're going to see in your G code. Inside the software, it's just a checkbox, and it's of the 2 types.
Yeah, and you guys will see the same tool path. Everything's going to be the same. The only thing being affected, like Mark is saying, is just the G code only.
Yeah, so if I show the wireframe, it's still doing the exact same pocket. And there's nothing here that would show us pretty much any difference. It's until you post the code that you see the difference. Okay, so if that is clear, we do have a list of questions. Let's see what we had from the last time. This is one we were going to talk about, but I think there's actually a shorter one I want to make sure we get to, because it was one of the ones from last week. There it is. So this was, I believe, Brian's question right at the end. Can SolidCAM import X, Y, and Z points, positions from a point cloud? Yes. So the idea is that if you have any kind of CAD data, you can import it inside SolidWorks, translate it into SolidWorks geometry, and then you can use it. So if you have a point cloud, yes, absolutely, you can do that. Now, what you can do with that after you've imported it is either turn that point cloud into surfaces if you have that ability with your SolidWorks, if you go that far into doing surfacing. If you are just using point cloud data, as in it's a bunch of vertices of your solid, you can do that as well. You can use define by 3-point associative. Let's just go into this section here. So when you are first defining your part, you have to set up a coordinate system and you have to choose a post. So choosing a post, no matter what geometry you have, you're going to choose a post. But your coordinate system, you can define your coordinate system pretty much with any geometry you have on screen. So if it is a point cloud, you're going to most likely use something like by 3 points. You choose your origin, you choose an X direction, choose a Y direction. As soon as you have X and Y, you have Z, so you have your coordinate system. That could be really complex if you just have point cloud, because once you've done this, there really isn't anything for you to assign as your target or as your stock. You can put a box stock or a cylinder stock around your part, but ultimately you pretty much are using just point data for simple toolpaths, drilling, pocketing, profiling, if you have that geometry at least. But with points, there's not much where you can do unless you turn that into something. But yes, you can absolutely bring in X, Y, and Z point cloud data. If you brought in a coordinate system from SolidWorks with that point cloud data, let's say it was part of the initial file, then yes, you can convert that as well.
As well as if you guys are getting just a 2D sketch from engineering or a customer, you guys can program an entire part off that. You will not have the associativity like with levels and stuff like that, because you will manually have to type those numbers in there, because it's only a 2D model at that point, or a 2D sketch at that point, and not a full 3D model. So all your depths, all that will have to be manually inputted in based off of what the blueprint is showing you.
Absolutely, and that is in the truest sense what a 2.5D file would be, because the 2D is from the sketch, like Kevin said, and then the half is your input of the depth. So you can work off of that sketch data as well. Okay, so there was...
Brad's just looking for if he can have a copy of that part.
Yeah, I think I'm not sure if this is one of our demo parts, but I guess I don't think there's any issue with giving it this. Obviously, with this, don't produce this part because I'm not sure on this post. So you can have this as an example, but I don't know if this is actually something you could produce if you were even planning on producing it. But okay, so let's get to that major question. And that is this one on screen here. Okay, so this is something we touched base on in the last episode. It was Jake's question of should he define the stock before he even knows what stock he's going to use? And I would say yes. You want to get all this on, not on paper, but metaphorically on paper. You want to get all this programmed. You can get all your toolpaths done, because remember, your toolpaths are based off the geometry from the target. Any stock recognition, anything like that, obviously is going to be up to date as to your stock. But if later on you change your stock definition, either using the box definition or 3D models, then you can always do a synchronize and calculate to the new stock. Now, if you're making your stock out of something that is a series of little stocks together, and I think that's what Jake's question is all about, because he mentions that he's making this out of a foam similar to wrench shape. So if he's got little blocks that he's gluing together or somehow just affixing together to make his overall target, that usually becomes a complex thing, because you're not sure what you're going to have available to you in terms of the little pieces. And I've run into this myself, where you're building blocks, you're laminating all this stuff together just to make this larger shape. Even in that case, you're going to do that using the 3D model option. And then when you realize what 3D models you actually have, then you can go back and modify it. And if you've made it everything correctly, let's say you make your stock out of a series of blocks and you make it as an assembly. If you've mated them all together, then when you change the shape of something, those mates should just realign and then set that thing back up as your proper stock. So there's a lot of automation, a lot of, I forget what they used to call it on the design side of things, but there's a lot of intention you can put in your assemblies, in your designs, that when you change one thing, it just automatically updates itself. And then inside SolidCAM, because all of our stock recognition is watching for that, it'll update the toolpath as well. So long-winded answer, but yes, I would say design your stock, assign your stock, and then just allow the associativity, allow the stock recognition to be your benefit, where you can just get all your toolpaths on screen. And then once you realize what size of stock you should be using, then you just change it, synchronize, calculate, and then repost your code. Does that make sense?
Perfect.
Perfect. Okay. Now, there's a question from Frank.
Yep.
So unrelated to today's topic, but is there a simple way to mill a pocket that is interrupted by a slot in the solid model? For example, if I have an internal hex, but there is a deeper slot that goes through two side walls.
Yeah, so this kind of goes along with almost with what Mark was just talking about. So for his pocket, sorry to take this more, Mark, if you want to go.
No,
so when we're using iMachining, now iMachining has the 3 geometry types in there that are all recognition feature, automatic recognition feature. So what it's going to do is it's going to look at the stock of what's already done from all the previous operations and adjust the toolpath from there. So obviously, if we have a slot going through there, we're going to have an interrupted cut. So what iMachining will actually do is it will look at that slot, because that material is already missing, and automatically adjust for that. Now, if you're doing just a simple pocket operation, in that particular case, what you'd want to do is chain that slot as one chain and then chain your pocket as another chain, and you would mark that slot as an open edge. So it's basically telling the software that that material is gone, and we don't need to machine that at all.
Perfect example of how you could use the chains to your advantage to do that. And you can also, like Kevin said, set open edges. But let's say the slot is not there currently in the state of your operations. The slot eventually will be taken out. But if you have a pocket where the slot is part of the final target, but at this time all you're doing is that one pocket, how do you jump that corner? Always remember that you have the point-to-point option. You can actually go from one vertice to another. So you can actually close that pocket for you. So that actually ends up being a closed line. So if you already have the slot there and you're looking to jump the gap, like Kevin said, you want to open some edges and take advantage of that open area, you can do that. If the slot is not currently there and in the order of operations you're just doing the pocket right now, you can use point-to-point to close those edges. Or always remember as well that it doesn't matter which direction you go with your chain. You can go like that, you can go down, across, like that, and all you're looking for is that projection to the tool plane. So if that slot makes part of the wall, then you can go up and down in your chains as well, and then just get that to be part of your pocket geometry as well. That makes sense, Frank?
Yeah, I was thinking it was a slot through there, so you didn't want to have like an interrupted cut going through there.
Well, I mean, to me, it's always the order of operations as well, because a lot of the times we have all these interfering features that one of them has to be done first. So it's either an interrupted cut right now, or it will be an interrupted cut once that slot is cut first, and then the pocket. So it's a matter of, probably need to see the actual part to understand what order things are being done in. But the geometry you have on screen can always help you. You can always choose your edges and then get them to be projected to represent the status of the pocket right now. Or if there is a slot through that pocket and you want to somehow get SolidCAM to understand that there's that interrupted cut, then it's like what Kevin said, just set the open edges. And then you're actually telling SolidCAM that even though you have this full pocket, there is a slot that's missing. Okay, so the point-to-point makes sense. If I move along the z-axis, select geometry. So I'm just reading Frank's question again. So the point-to-point makes sense. If I move along the z-axis to select geometry, can I still choose a consistent z level for actual machining? If I understand the question, when you choose the geometry in a 2.5D toolpath, all of that geometry gets projected to your tool plane. So it's basically, it eventually will be a consistent z level. Because remember, when you get into the toolpath, whether it's profile or pocket, you are choosing a depth, an upper level and a lower level, or an upper level and a pocket depth or a profile depth. So it eventually will be a consistent.
Go ahead and chain what you were just working on, chaining, going up and down there, and then we'll turn on the show working plane.
I already have it on, so let's see what happens.
That may help out.
It's not actually getting projected to the tool plane there, but let's see what happens. Let's go here, then we'll go down, grab that around there. Let's say I grab that all the way around, so I'll do up to entity constant z, and I want to go, let's say, all the way over to here. So it chooses all that for me. Let me turn these back off. We'll go back up and then across, and then I'm going to turn up to entity and constant z again, just to get over here. So that closes the chain for me. So I went up and down in z, but if you look at the purple, that's projecting it to the tool plane. So that is the entire hex.
Yep, so it doesn't matter if your geometry goes up, down, it's all getting projected up to one level, which is a real nice feature inside here.
Yep, so let's say I set it to something above, let's do 1 inch above that. And then my pocket depth, let's set it to this face as well, but maybe only 1/2 inch above that. And I got to get my tool, so let me choose my tool. So I'll choose tool 3 so we can get a very similar looking pocket to what we had before. Yeah, okay, so that's why. Let's not make this so high. Let's make this 0.4. And we'll make this 0.4 as well. So you see, even though our chain went up and down in z, it's projected to the same z plane.
Perfect.
Awesome, okay. And that actually looks pretty cool. I like that. Little spiderweb looking thing. Okay, so we have about 6 minutes left. Okay, so there was one actual really quick question that came in right before class. Let me open this up. And I believe this was from Brian. I think Brian is here today. Let's see the list. Brian is here, awesome. So Brian, you were asking about, I think it's probably because you did you're probably looking at an older version of SolidCAM versus a newer version. But yes, SolidCAM now exists in the Tools menu. here. And then to get your recent CAM parts, you either go here, so you can see the last 10 that you had open, or you can go to Browse Recent Parts and see some thumbnails of the last couple of parts that you had open. Now, I guess you were asking if there's a quicker way to get to that. Well, in 2020, we actually have our tab here on the side. So now you can just go right to Open, Browse. Recent parts are on the bottom here. So is this sort of what you were looking for? If Brian is still here. Okay, we'll see if Brian can, oh, there he is, okay. I'll have to try that, okay. So yes, so this is actually, let me just show you which version I'm working with. This is 2020 SP1, and Kevin, correct me if I'm wrong, but I think that's the most recent one.
Correct, yep.
Okay.
And if you want, there is another way to go about this too, is go ahead and close out of this SolidCAM project for me, Mark. So right now, once it's compressing, so right now, there's nothing up on Mark's screen if you wanted to go through to the recents. So Mark, go ahead and add a custom button. So if you right click on that top ribbon, toolbars, and click the one that says SolidCAM. SolidCAM new, I think it is. Oh yeah, maybe it's that one. I always forget which one it is. So right here, what this will do is it will open up a toolbar on your SolidWorks screen. So at this point, you can do a recent parts, you can close out a SolidCAM, you can open up your settings, so you don't have to go to the actual tools, SolidCAM, open, and you can go right to, it's a quick feature just to get to right to there. And that's what I use quite a bit, is clicking on that recent parts, and it brings it up that way as well. So it's a little less mouse clicks to get to there. Is that going to help out, Brian?
Okay, awesome. All right, so let's go back on the list here. So there was a, okay, so here it is from Jake. Is there a stay on surface function to machine across gaps in regards to the hex pocket over an existing? So stay on surface, it depends on the toolpath, but yes, it's kind of like we were just talking about with the pocketing and the profiling. When you choose your chain geometry, it can go up and down in Z, but it's the levels that control the keep the tool down, stay on surface kind of thing. If you're talking about more of a 3-axis or one of the 5-axis toolpaths, then that's a whole other story, because what you're doing there is you're controlling the actual movement of the tool across the surface. So there are definitely ways to tell it to keep the tool on surface as well, but it's not the same as jumping gaps or anything like that. Okay, so Brian's question.
About his post, if he's using the SolidCAM 2019 post, will it work for 2020? And yes, it will, Brian. So not an issue at all.
It depends on if it's multi-axis. If you're using a multi-axis post, just get a check done by our post team. So you want to submit a ticket just saying, I've updated to 2020. Can you just see to make sure my 2019 post? It's just a check. But a lot of the times, yes, like Kevin said, it is a direct translation. But it's always a good idea to just check your multi-axis posts, mill-turn posts, 5-axis posts with the post team, just to make sure, because there's a lot more going on there than that might be different depending on which version you're working with. Okay, I think that was it for all the questions. I don't have any other questions here. Questions in the list. Looks good. Okay, so like I said, like I always say, SolidCAM Live is every day at 2 p.m. Eastern Time. We're going to be doing this until, I guess, the end of this week. And if the response is good, or if unfortunately if the situation the world is in right now continues, we might continue this. So if you'd like it to continue, just let us know. Feedback is always welcome. Questions, you can always send us your questions. Most of you have Kevin's email, but just in case you don't have mine, although you should, because it seems like everybody's been in attendance every day, so everybody should have this, but just in case. I'm trying to type and talk at the same time. There's my direct email. So you can always send me your questions. Send me, if there's a part you don't mind sharing with the team, with the group here, send it to me. We can always take a look at your part. This is a half-hour free training. It's a good example of what we do with the direct training. So if you're interested in direct training, also give me a call, email me, and we can actually do some live one-on-one training. We use GoToMeeting for that as well, but you actually can dial in with a regular phone, or if you've got a mic and speakers on your computer, you can talk to me directly. Myself, Kevin, Greg, all the guys you've heard on a KevCam channel, they're available for training. And that is something you can get done. If you don't currently have training hours, you can contact your local salesperson and they can give you a quote on how that's done. In addition, if you know anybody that could benefit from using SolidCAM, we love to work with you guys on finder's fees. So if you actually know someone that would be interested in getting their own copy of SolidCAM, let us know. If they get into a demo, if they purchase, there's certain percentages available in terms of finder's fees. So please, if you're interested in that, let us know. But if not, I will talk to you guys tomorrow, 2 p.m. Eastern time. And you guys stay safe, your family's safe. Hope everybody is going to do well in this coming time. So we'll talk to you tomorrow.
All right, thanks everyone.